All right. Welcome to my talk on Merlin. Came up with this crafty title right here by using ChatGPT. I was like, hey, can you make me a title for this talk? I got a tool called Merlin, and it has some new features. Can you come up with the rest, please? And I did, but let me get started. All right, this is me. Actually, everyone here already knows who I am, so this is not very useful. But my name is Russell Vantile. You can find me on Twitter. X is no longer Twitter. The artist formerly known as Twitter. Neon Dog is the handle I go by on there. I do keep a separate Twitter profile just for Merlin stuff. At Merlin C2, I try to only use that if I'm going to post about Merlin stuff. I didn't want to mix up my personal account, which I also don't post anything on, with the account I use for the tool. So you can find the code at the repo. If you really want to get connected or talk with me about it, the Bloodhound Gang Slack is probably the best place to go and talk to me in there. There's a Merlin channel in there, or you can find me in the GoLang channel, or you can send me a DM. So send me a message on Twitter or Slack if you're interested in talking more about it. Or do like everyone else does and just make an issue on GitHub so you can ask me a question. Anything works. So what am I here to talk about? A while back, I decided to write a tool in Go called Merlin. It's a post-exploit command and control tool. I started quite a while ago. At the time, I was looking to use the HTTP2 protocol, and there was no other library support in other languages like PowerShell. Go was the only one that had support, so I decided to go with that language. But both the server and agent are written in Go. It was a good learning experience. It was a way for me to pick up how to write in Go. Knowing what I know now, it might be better to switch to another language for an agent, but Go is pretty useful to get going. So what's a little bit unique about Merlin that most other C2s don't do is the communication channels. Again, at the time when I wrote it, HTTP2, nobody else was doing it, but now the library support's just kind of there and Go. So if you can set up a web server, it automatically has HTTP2. But Merlin's the only one that really uses HTTP3. Have you heard of HTTP3? Yeah, HTTP2 over quick is called HTTP3. So that's a unique one. That's UDP based with like TCP like control. What's interesting about it is not many things can detect it or pick up on it too much, but for most of the enterprise organizations I've looked at, they don't actually allow it to leave their network. So it's like useful, but not useful at the same time. I've heard some of the less secure companies don't really do egress filtering, and it works there to kind of get out of their network. But Quick is used by Google all the time. Like if you open a Chrome web browser and you go to YouTube, it's trying to do Quick. It'll fail back over to TCP over HTTP, but it does try to use that. So another interesting thing about HTTP2 that Merlin does is it uses HTTP2 over clear text. That's not officially supported by any of the web browsers. So like there should be no web browsers in your actual organization using HTTP2 over clear text, but it is supported by the protocol spec. So Merlin will do that too. I've had good success over that. You just pipe it over port 80. It'll keep one steady connection over, and I've had organizations not see that leave their network whatsoever. So another neat thing about Merlin is it uses opaque key exchange. It's an actual RFC protocol and how you can kind of do secret exchange across the network without passing any secrets out. All right, what other things does Merlin do that's a little bit different than other frameworks might do? I use JSON web tokens for authorization. So every request that goes to and from the server has its own JSON web token that's good for just the lifetime of the C2 comms. That way you can't really take and replay an old message or anything like that. The token will be expired. Another thing Merlin does is a little bit interesting. If you guys heard of JSON web encryption, it's actually also an RFC spec on how you encrypt data in a JSON-like format. It uses AES 256 key wrap per message, so every message has its own AES 256 key that goes on every message going back and forth. I really tried to prioritize how well the data is protected while it's being transferred across the network. Documentation, if you want to learn more. I try to do a good job with documentation, but it gets to be not fun part of actually developing is writing the documentation at the end. So some people ask me, why did I call it Merlin? Again, when I initially started looking at the HTTP2 protocol spec, and in that protocol spec, if you're doing an upgrade, it uses what's called a magic string. You can kind of see this is like Wireshark's breakdown of the magic string. So this is, a play on the magic string. Merlin, magic, get it? And the way that it finishes the negotiation is, you can see over here on the left-hand side is that it sends the word prism across to actually show the network that I can actually do the upgrade and can actually talk HTTP2. What's unique about Prism is, do you remember that thing that got released a couple years ago where one of those three-letter agency was like decrypting traffic and then getting back into it? It's a play on that thing right there. So anyways, that's why I call it Merlin, just a play on the magic string and the HTTP2 connection. It's going to take a time to go over some of the existing features. It talks about some of the new features I've added, but I figured I'd just show you some of the existing things that I already can do. One of the unique things that Merlin will do is it has dynamic J3 hash on it. If you've heard of that, that's a way that you can look at TLS packet configurations and fingerprint stuff. Well, Merlin, you can pass it just an arbitrary J3 string, and it will transform its client to actually look like something else or look like something different. It's really neat, but you can also configure your TLS client in a way that can't actually talk to the server, so you can brick it as well. So it takes a little bit of skill to make sure you use it correctly. Another thing Merlin does, interestingly, is it's Go-based, so it's unmanaged code in Windows, but you can actually load .NET assemblies into the Go process, so no fork and run. Load them into the process. They'll stay there in the agent's memory, and you can just keep re-executing them on target over and over again. You can also have the Merlin command and control channel just use what's called parroting of browsers. You can just say, I want it to look like Chrome, and it will just start using user agents that look like Chrome or Firefox or any of that kind of stuff. It helps when you're in an organization, you're trying to get out. I've seen some organizations where if you have an old user agent string, they're like, this is not present in our environment, so it sticks out to them. Merlin, by design, does not have a database. So if you close out the web server, everything in memory is gone. It doesn't have anything anymore. I purposely did not want to write a database. But what I can do is what I call orphaned agent handling. So if you start the server back up and a new agent checks back in, it will renegotiate the session, redo authorization and authentication, and then it will put everything back into memory. So I tried to make it resilient in that. I don't know if any of you have used a C2 framework in the days of old and accidentally killed it, and you're like, oh, now what am I going to do? So I tried to really make sure you could recover from that situation. You can do payload obfuscation using Garble. It's one of the ways to easily win against static strings. It's kind of built into the makefile. You can just run it. Most of the other Go tools do that as well. And I tried to make Merlin pretty versatile, so you can compile it into a DLL. You can compile it into shellcode. You can compile it into Linux shared object files, so you can do that, any kind of side loading, any of that kind of stuff. Again, not unique, but it kind of helps you get to where you're trying to go. Other interesting feature is it has SOC support. Again, most C2 agents, the good ones at least, have SOCs, but that one took a hot minute for me to get into the system. But if you need SOC support, it has that in there as well. The one that I really like is it can just patch arbitrary Windows memory. You can literally just give it the DLL and the function name and what bytes you want to patch, and it will just automatically find them, patch the bytes to whatever you want. So good if you're trying to unhook a specific function call. You can just pass that in and it will change. You can also just arbitrarily read certain sections of memory to see if there's a hook there to begin with. And then it also has Windows access token manipulation. One of the frustrating things that I saw when working with Cobalt Strike is I wanted to see what my process and thread token were. So in Merlin, you could just do token who am I. It will tell you your process token, your thread token, your privileges, your integrity level. It'll tell you all that stuff with just one little command. So it kind of helps push back against that. Shout out to Cody over here. I also got Merlin will work on Mythic, so you can use it in a standalone as a command line interface based. Some people don't like that because it's not multiplayer. I say if you use Screen, you can use 1.5 people at a time. Both people can issue commands. But like Cody said in his talk, I do not want to write a front end, so I'm not planning on writing a front end. But you can actually use Merlin through Mythic as well. The code is mostly the same, but you lose some features. Merlin on Mythic just uses Cody's HTTP profile. And so you lose all of the things like HTTP2, you lose HTTP3, you lose JWT authorizations, you lose JWE encryption on the payloads. All Mythic does is uses the AES encrypted blob of data, just sends back and forth on that. So, but it can be used that way if you want to use it that way. Okay, what did I add that is new? Probably, I know there's not a lot of text on the slide, but it has taken me about 5 to 6 months of my free time to add peer-to-peer agent communications into Merlin. There's a lot of stuff I had to do. You can do TCP, UDP, and SMB, and you can do those bind, which is what most people use. Obviously, it binds to a port on the host, you connect in, but you can also do reverse. So if you're trying to get into a segmented environment and you can't talk into it, but you can execute code, you can have it call back out to you as well, and it connect to any parent listener going in that environment. In order for the SMB agent to work, the parent host has to be at least a Windows host, because I don't have a Linux library for SMB connections, but most of the times you're in Windows environments anyways. Another thing that we like to do in the peer-to-peer is what I call passive communication. So, agents check in at some life cycle that maybe say every 10 seconds or every 30 seconds. What I mean by passive communication is that if you tell the agent any negative number, it will not communicate on the network whatsoever unless it has something to say, or the server needs to tell it something. So if there's no tasks being issued to it, it will just sit there and sleep and not send any network traffic for the entire time. So I'm not sure how valuable that will be. I have had detections off Cobalt Strikes, like SMB beacon traffic, just kind of going back and forth and stuff. So maybe it'll help out in that aspect on there. I tried to make Merlin a little bit more modular this time around. I'll get to why I did that here when we get to the lessons learned section. But what I've added is new authenticators. Again, I use Opaque. Opaque is a way to do key exchange across the network and also do authentication. Again, that's an RFC spec, but it's a little bit overhead. You have to go through about 9 steps to actually make that happen. I have it so that it'll happen back to back to back, but it's a little bit much. So I've also made it to where you could just have none. You could just do no authentication if you want your agents just to check in. That way it's quick like that. I've tried to make it extendable, so as long as you have a function that exports authenticate, you can literally write your own authenticate package. It just needs to actually export that. So I've tried to make it a little bit more modular this time so people can adapt it to whatever they need. I did the same thing with authorization. A second ago, like I mentioned, we got the JSON web tokens, which come in handy. People can't replay attacks very well because it does a JW authorization, but I have seen a lot of people that run Merlin in a lab environment or in VMs. Their VMs get out of time sync, and JWTs work by needing to be on the same time. So if your VM is out of sync by 10 seconds, the agent will fail to check in because it's like this JWT is no good because it's only good for 10 seconds ago or in the future. So I've made it to where you can actually just disable that feature now as well. If you just happen to not want JWT authorization, you can just turn that off altogether. And then in the past, you had to, whenever the server started, it created a key, but it never told you what it was. It was a unique key per instance. But now you can actually kind of configure that key to be whatever you want. I've also kind of moved to a little bit, I'm kind of going for the same thing as Cobalt Strike with the malleable profiles. Historically in the past, it was a GOB encoded string that was turned into a JWE, which is like a fixed thing you would see across the network. But now I've changed it to where you can do any of these data transforms you want in any order that you want and as many times as you want. So if you want to AES encode something 25 times before you send it, you can do that. If you want to stack it with RC4, base 64, and then GOB encoding, you can do that as well. So I'm hoping to provide some flexibility to operators to kind of change the network traffic so it looks like whatever you want it to look like on the network. Those are also extendable. All you have to do is be able to export a construct and deconstruct method. And so it just takes data in, does the construction, deconstruction, returns back when it's done. So I'm trying to make that extendable feature out there as well. Just a couple last minute miscellaneous things that I've added over to Merlin is you can if you're connected to one web server, for your C2 and you want to just move or migrate, you can just issue a connect command and the agent will just reconnect to a completely different server. And because I have that whole resiliency thing where it can take orphaned agents, it will just kind of do the whole negotiation thing again, so long as the pre-shared key is the same on there. And then I'm trying to restructure the command line interface so that I can separate it out, because right now the command line interface and the server are the same package. So when you run it on a server, they have to be in the same host, which could be frustrating because sometimes the assemblies you want to execute are not on the server where Merlin is. They're on your actual workstation. So I'm hoping here in the next 2 or 3 months that I can actually separate those two out for everything. And then I just put help down there. Right now, if you want help, you have to go to the web page to do it, but that's not very useful when you're actually in the command line interface and you're trying to do something. So I'm adding in this help on the command line. I know it seems like a basic thing, but I never put the time into it, but I am now. So you can just issue help, see examples of what it looks like. It'll tell you all the notes and that kind of stuff. It should be a 1-for-1 correlation to what the website says, so that way you're not missing any information by going there. I was going to cover just a little bit of lessons learned that I learned from developing and writing the code this time around. I've been working on Merlin for about 5 years now. And so when I started writing Go, again, I was learning how to write Go altogether. And every time you go back and look at your code, as every year goes on, you're like, ooh, that was not a good choice. So I figured I'd talk about some of those lessons learned that I went through on this time. Again, that kind of went back to the development principles. In Go, you can't have cyclical imports. So like if package A imports package B can't ever import package A ever again. And when I first started writing the peer-to-peer communications, I kept getting a bunch of cyclical imports over and over again, which basically means I had a very bad project design when I was writing the agent the first time. So I had to go back and try to restructure the code. I did actually talk to our Bloodhound Enterprise team developer and got a little input from them on like a good way to do that. They set me straight. I tried to implement what's called domain-driven design. Some concepts from that, some concepts from the solid principle. What I ended up doing was creating entities repository, so like just the structured definitions live in their own thing, so that way they can only be imported once and they import nothing. I try to go for repositories, which is basically the in-memory data store of where everything goes, so like stuff gets saved in a different package. And then services to actually interact with or manipulate the data. So I try to get a little bit more professional in my design decisions on like putting stuff out there. I also separated out the servers and the listeners. Before there was just the HTTP package, and that was the server and listener concept were the same. That's where the web servers get to. But I separated that out. So one of the big problems with peer-to-peer message traffic is the parent agent doesn't know anything about the child. It just gets data and then sends it back to the server. It can't actually read the data like it's like onion routing. It doesn't know what's going on. But I learned the hard way that if you're going to send data across the network, you need to have it in some kind of structured way so that way you know when you're done reading it. And so I ended up going with TLV or tag length value. So you tag the packet, you put how long the data is, and what the value is after that, like the actual encrypted or encoded data. That took a while to actually get right. Because you had to do a lot of data processing to get in there. I also ran into chunking problems. With TCP, you can just give it a giant blob of data and say, hey, send this, and it will break it up, but UDP won't do that. And so there's obviously UDP has no session handling. So I had to go in and actually set file size chunks to actually take a large amount of data and start breaking it up into smaller chunks and then sending it across the network. So that took a little bit of time as well. All right, what else I got? A bunch of error handling. Like when I was writing the agent, again, I'm really trying to go for resiliency. I'm trying to make sure that the agent works under all conditions, that you basically can't lose access unless you wanted to lose access to your agent. So it takes a little bit of extra steps on like things you got to think about to try to handle. So like if you have a UDP connection with something and the parent agent never sends you traffic again, how do you know that they're done talking? How do you know that the child agent isn't there anymore? So even same thing with TCP and SMB. So I end up having to go and like work with like trying to detect the TCP connection breaking. You can detect that because that's session based, but UDP you can't. So I had to like go with, if you're starting, I can only tell when I'm starting a new session by some data that's appended to the front of it. So like for UDP, I had to say, is this someone new talking to me that I never talked before? So I could set up a new session going back and forth. The read and write on like a pipe going back and forth, like the parent talking to the child talking to the parent, are two different Go routines. And if one of them detects that the connection is closed, the other one will keep trying to send because they're in two separate Go routines. So I had to actually spend time to like do like signaling between the two different Go routines. So that way one would know the other is done and they could both reset at the same time to kind of accept new connections. I learned the hard way that, so first I was testing SMB peer-to-peer on like the same Windows host, and that was working fine. I could send like 20 megabyte files and it would have no problem. And then I tried to do it across the network and it was no longer working. And apparently there is an actual file size limit per packet when you're doing SMB across the network versus the same host. So that took me quite a while to troubleshoot and figure out what the size was to do that. So again, the lesson learned, there's a difference between coding in a lab versus actually going out into production and trying to use the agent. So that was one of the things I had to learn from. Also, sending speed in a lab, UDP is, again, not session-based. So when you're doing UDP peer-to-peer, it just sends the packets as fast as it freaking can and goes pretty fast. And what was happening was Go was sending the packets faster than the receiving VM could actually process them. And so they were getting out of order. And again, UDP is not session-based. So it's like, I just got a bunch of on-order data. What do I do? So I had to add some artificial time delays in there. That's mostly an artifact of being in a lab environment because they're just VMs on my host, not actually in a production environment. I don't suspect that you'll have that problem in an actual client network, but people will use Merlin a lot for like CTFs or CCDCs or that kind of stuff. So I tried to make sure to put that control in there for UDP packets. Again, what happens if the server restarts? If you have one parent with 20 children, how does the server know that there's 20 children there? So I had to like add some error handling to like go through and like get the parent agent to resend over what its leaked agents are. If the server needs to know that it has leaked agents, so it knows how to send the messages down and like what path they need to go through to get there. So that was an interesting one. And also in Merlin, like I mentioned, you can kind of stack the way you want the data to look, but the server needs to know what data is expecting on that listener on there. And I already know for a fact that when I put it out there, people are going to set up different transforms and not set it up correctly in a listener. So what I do now is I get data, I try to see if I can decode it, but if I can't decode it, I basically brute force all the listeners to see if any of them can do the decoding with a pre-share key and like the encoding sequence to try to, again, recover that scenario of, oh, I forgot to set the listener ID to the right thing. Has a little bit of error recovery in there to kind of brute force and go through that. That's it. That's all I got. You know, any questions? Anything I can answer for anybody?